In this proposal, I present my idea of how I would make a space elevator as simple as it is possible to imagine. I will start by describing how I would do the apex anchor, located at 100,000 kilometers, going through the geosynchronous station, located at kilometer 36,000, until reaching the surface of the Earth. I dare to say that Panama would be a good candidate for the location of this space elevator. This country offers many positive qualities that make this project viable. We are close to the geographical equator, we do not have earthquakes or hurricanes, we are the hub area of Latin America, and it is not a simple coincidence that we have here the Panama Canal. To make the apex anchor required for this proposal, I will try to use a minimum number of conventional rockets. In this proposal I will use 18 Roten C9 modified rockets. These rockets could carry up to 3 tons, and without fuel they weighed about 22 tons. So, we will say that each one weighs 25 tons by 18 of them, which gives us 450 tons. These Roten C9 will be mounted on reusable rockets, which will take them to a low orbit, LEO. And from there they will continue their journey with their own propulsion until reaching the 100,000 kilometer just above the location on the surface. Important note: the low-orbit rocket presented here is reusable. For the moment of re-entry, with the use of its propulsion plus the propeller system used in the Roten C9, tip jet propellers, they will provide the rocket with a smooth and precise re-entry back to the launch pad. Returning to kilometer 100,000, the modified Roten C9s will pile up and must be coupled either remotely or with the help of astronauts. Important note: one of the modifications of the Roten C9 is that the propulsion system type, tip jet, will be replaced by a coupling system. First they will line up next to each other and then rotate 180 degrees, and using the docking system, they will come together until they dock 3 by 3. When all the Roten C9s are assembled in threes, with the help of astronauts and parts sent from the surface, a circular metal framework will be assembled and the Roten C9s will be placed in a triangle as shown below. And when the 18 Roten C9s are attached to the circular metal framework, everything should look as shown below. Important note: the astronauts are to real scale to give an idea of the dimensions of the project. In this representation, just below and in the center of the central part of the apex anchor, an assembler robot will be permanently added. Later its operation will be explained, plus 8 circular platforms which have adjustable arms that will serve to push and clamp the tethers safely. The assembler robot is described below. From the surface, rolls of tethers will be sent, which at each start will have a 30-meter-long flexible but at the same time extremely resistant rod, and at each end of this roll will have 15 meters of only coating. And with the help of astronauts, the first 15 meters of this rod will be exposed and will be inserted within the final 15 meters of the previous tether coating, and when circulating inside the assembler robot, it will be welded, melted or glued, and it will come out as a single unit each tether section assembled. In other words, it would be like inserting a foot inside a sock. Only in this representation the rod represents the foot and the sock is the last 15 meters of the tether. Important note. In this representation, each coil coming from the surface contains 2,000 kilometers of tether. Adjustable arms. The adjustable arms are described below. There are two types of adjustable arms. One has a motor with wheels that is used to push the tether as it comes out of the assembly robot. And the model that has plates that serve to press and secure the tether, thanks to motors that allow it to separate or tighten the tether. The adjustable arms that have a clamp are attached to a hinge on the upper platform that allows it to swing without coming off and shortly before the assembler robot begins to remove the tether. These arms will separate, thanks to their motors located at the end opposite the clamping plate, as shown below. And when the tether needs to be re-secured, the arms close back up and press the tether down. As the rolls of tether arrive from the surface, each section is joined by the robot assembler, then pulled out and pushed by the motorized arms to form a single tether measuring 100,000 kilometers long. In order to prevent the tether from accumulating under the platform, where this tether begins, a robot with multidirectional propulsion will be attached to it, which will pull the tether as it comes out and always pointing towards the Earth, specifically towards Panama. And as this multidirectional robot runs out of fuel and/or the cable becomes too heavy to pull, it will need to be replaced with a new and/or more powerful one. This process will be repeated until completing the 100,000 kilometers of tether necessary to reach the Earth's surface. While the assembler robot is fed with the shipment of tether coils to make the 100 kilometers necessary to reach the Earth's surface. On the surface of the Earth where the tether is planned to arrive, a structure very similar to the Atlas F-type nuclear silo will be built. This is due to safety. If something fell from several kilometers high, the use of a helmet will not help at all. This structure will also serve to maintain the climber, and as they leave the silo, the merchandise will be loaded or unloaded depending on whether it comes or goes to space. Climber's explanation. I developed two types of climber. The first one is capable of carrying merchandise inside its special containers. There are two and each container has a volume of 30 cubic meters. The second climber has the function of helping the first climber when he goes up or down the space depending on his transit. And that's how it goes up and down the tether. Each climber has 8 motors that press the tether, instead of placing them tangent with the tether. They moved from their tangent point to almost the center of the wheel. In order to achieve traction that will help the climber to go up or down to and from the space. Important note. If necessary, the wheels will move even more to increase traction. Meanwhile, in space after the silo or base on the surface is finished, in the last kilometers that are needed to connect heaven and earth, in this example we will say 1,700 kilometers. The tether will be coupled to the necessary amount of rockets that pull the tether towards the silo or base and correct the course so that they leave the tether as close as possible to the silo or base. When the tether arrives together with the rockets to the surface of the Earth, the surplus of tether will accumulate as it is pulled to the surface thanks to the gravity of the planet. You should wait at least a month for gravity to continue pulling and tensing the tether throughout the 100,000 kilometers. After more than a month waiting for the planet's gravity to continue pulling and tightening the tether, the tether will be placed in its special anchor at the bottom of the silo, without losing the tether's tension. In the same way, we will proceed with the assembly of the 8 climbers. Important note. Remember that the astronauts are on a real scale to give an idea of the dimensions of the project. Important note. Due to the lack of clarity, the presentation clarified that the silo has floors from the beginning to the bottom so that different teams can work on all the climbers. Both those with containers and the helper climbers. In the silo, the staff will proceed to change the climbers that have special containers for a resistant metal plate. Later their use will be explained. And once this is done, the climbers will be sent in pairs, the one with the metal plate, and the helper is attached below. Reaching kilometer 100,000 will take the climbers a couple of weeks. In the time it takes for the climbers to reach kilometer 100,000, a group of astronauts will be on the platform at kilometer 100,000 changing all the plates of the arms that were used to pull the cable that was coming out of the assembly robot for ones that have prehensile plate. Once all the wheeled motorized arms are replaced with prehensile plate terminals and the climbers have reached the platform located 100,000 kilometers away, then it's time to relocate the platform. And this is how it will be done. The first prehensile arms will open to allow the passage of the first 2 climbers. Remember that each set of arms are attached to special hinges on the platform above, and then close just like ships do, transiting through the locks of the Panama Canal. Important note. I moved the support cables to better appreciate how the coupling process will be. Each lock will allow a couple of climbers to pass over and over again, but always maintaining 3 support points with respect to the tether. This process will be repeated until occupying the 4 locks that form a platform. And with the supervision of astronauts, the last duo of climbers will climb in such a way that the metal or carbon fiber bar that the upper climber carries is at the same height where the 2 prehensile arms are. In this way when they close they will remain pressed to the climber and not to the tether. This process will be repeated in the following 3 locks, in such a way that each set of prehensile arms is holding the climber's bar. And when this process is finished, then I will have a mobile platform and I will be able to transport it 64,000 kilometers further down. Remember that each pair of climbers, climber with metal plate plus helper climber, is responsible for harmoniously moving each lock in such a way that all the platforms descend from kilometer 100,000 to kilometer 36,000. Important note: I changed the color of the platform so that it stands out against the background of the space. Once the platform reaches kilometer 36,000, the uncoupling process will be repeated, but in reverse. In this way I will have two platforms. The one I left at kilometer 100,000 and the new one at kilometer 36,000. Using the same mobile platform technique, I could take the two platforms located at kilometer 100,000. I would install them the closest to the Earth and that gravity allows me. In this representation we will say kilometer 800, and with these two platforms could make a orbit hotel. On land, we would have the same type of anchor style, Atlas F silo, plus the full-scale hotel, and for several days, instructions would be given on what to do and what not to do when they are in space, as well as how to use spacesuits in zero-G flight. And after the training, they could spend 48 hours in the hotel and enjoy the 14 comfortable rooms, spend time in space from the Vertigo Terrace, or enjoy incredible views in the room such as the beautiful Earth, hurricanes, possibly an eclipse. Important note: I forgot to mention that each pair of climbers is powered by the Multi-Mission Radioisotope Thermoelectric Generator, MMRTG. These cells will provide the necessary energy to function, and at the end of their useful life, they could be mounted in a special container and sent to the Sun. Uses of the platform kilometer 36,000. One of the possible uses for the 36,000 kilometer platform would be to dispose of nuclear waste instead of storing it. And since the climbers work with this type of energy, some nation could dedicate themselves to this with great dividends. With a space shipyard, true spaceships could be built directly in space and would remain in space for their entire useful life, returning to the space shipyard only for maintenance. In this way, manned missions could be sent to other distant planets more efficiently.